Okay, so something huge is happening all around us, but it's happening almost in complete silence. We're in the middle of a global race to replace the very foundations of our digital security, and we have to do it before a new kind of computer comes along and brings the whole thing crashing down. This is the story of how we're making our world quantum safe.
The heart of the problem is something that's already happening, right now. It's called a store now, decrypt later attack. And it's exactly what it sounds like. Adversaries, right now, are just vacuuming up massive amounts of encrypted data, your data, company secrets, government communications, and they're just holding on to it. They can't break it today, but they are making a huge bet that someday a new technology will come along that gives them the master key to unlock everything.
And that leads to a pretty chilling question, right? What if they're right? I mean, what happens when every secure transaction, every private email, every single secret we've ever locked away with encryption suddenly becomes an open book? The stakes here, they are incredibly high.
So what is this threat we're actually up against? It's really important to get this. We're not just talking about faster computers, we're talking about a completely different kind of machine that just changes the entire game.
Think of our current encryption, stuff like RSA and ECC, like a really complex digital lock. Its security comes from a math problem that's just ridiculously hard for any normal computer to solve. Like, find the two specific prime numbers that multiply together to make this gigantic number. Well, quantum computers, they don't just work faster. They're built from the ground up to cheat at these exact kinds of problems.
And this cheat code, it has a name, Shor's algorithm. This isn't just a theory, it's a real, proven quantum algorithm. It's the tool that takes those impossibly hard math problems and turns them into something a quantum computer could figure out pretty easily. It is literally the master key for all of our current digital locks.
So, the moment this threat became clear, the race for solution was on. And this wasn't some secret project cooked up in a lab somewhere. This was a massive, open, global hunt for the next generation of digital defense.
And leading the charge, right out in the open, has been the U.S. National Institute of Standards and Technology, or NIST. Way back in 2016, they kicked off this incredible competition, basically a global call to arms for all the world's best cryptographers, saying, hey, we need you to invent the future of security.
And let me tell you, this has been a slow, careful process. It all started in 2016. Then, for years, experts all over the world just hammered away at these new algorithms, trying to break them. By 2022, NIST was able to announce the first round of winners. And now, in 2024, they're publishing the final rulebooks for our new quantum-safe world.
So, after all that, what did they come up with? What do these new digital locks actually look like? Well, they all belong to a new class of security called post-quantum cryptography, or PQC for short.
Okay, and this is probably the single most important thing to understand about PQC. It is not cryptography that you need a quantum computer to run. Nope, it's cryptography that runs on the same computers and phones we all use right now, but it's built on completely new kinds of math problems, problems that we believe are tough for both regular computers and quantum computers to crack.
And these aren't just concepts anymore, they're real, and they have names. The new standard for general encryption is called CRYSTALS-Kyber, and for digital signatures, the thing that proves who you are online, we've got a few, like CRYSTALS-Dilithium and Falcon. You'll see most of them are called lattice-based. All that means is their security is based on a kind of math that's so incredibly complex, it's thought to be safe from any computer we can even imagine building.
But here's where the story gets even bigger. This massive upgrade isn't just about playing defense against a future attack. By building this quantum-safe infrastructure, what we're really doing is laying the foundation for a whole new era of technology.
Seriously? Think about it. A world that's secured by PQC isn't just a slightly safer version of today. It's a world where we can finally, with confidence, build out future technologies like 6G or truly advanced AI, things that demand a level of security and trust that we don't have right now.
Want a real-world example? Just look at the vision for 6G. Documents like India's Bharat 6G vision, they talk about a future built on things like quantum machine learning, immersive virtual realities, and advanced AI. None of that stuff is even possible without a digital foundation we know is safe from every kind of attack. This upgrade is basically the price of admission to the next tech revolution.
So I know this might all sound like it's way off in the distant future, but the last and maybe the most critical point of all is that this is not science fiction. This transition, this great migration to PQC, it is happening right now.
and the deadlines are coming up fast.
Governments are absolutely not waiting around. I mean, the U.S. National Security Agency, the NSA, has already published a very clear, very aggressive timeline for moving all of its most sensitive systems over to this new cryptography. That is a massive signal that the clock is ticking for everybody.
And just look at these dates. By 2025, that's just around the corner, agencies have to start using PQC for things like signing software. By 2026, it's for web browsers and cloud services. And by 2030, for a lot of systems, it's not a suggestion anymore, it's a hard requirement. The migration has already started, and it's only going to speed up. Which really leaves us with this one final, kind of staggering thought. All this work from cryptographers and engineers around the world is kicking off one of the single biggest, most complex tech migrations in human history. How do you upgrade the security of an entire planet? It's an absolutely massive challenge, but it's the one we have to take on to secure our shared digital future.